You're going to learn how to write equations that represent solution. You'll be given a word problem. Again, you set up as an equation. Equation, again, is this and that. It has an equal sign. So something, you have a mathematical expression or phrase with numbers. It could be with numbers. It could be with operations and with a variable or symbol. And it's equal to something. Another number, or it could be even a variable, another symbol. So before we do that, let's go over what is an equation. The equation, 15 take away x, and x can be a given number. We do not know what this number is. Take away is equal to 12. This is an equation because it's this and that. It gives the difference in length between a walking stick. Walking stick is some kind of insect that looks like a stick. And one other insect. If x is the other insect, which insect is it? Let's see if we can solve it without looking at our table. So we're going to use the guess, check, and revise. 15 take away a number will be 12. My guess is 4. 15 take away 4 is 11. Let me put a question mark here. I don't think so. So let me take another guess. 15 take away 3 is 12. So 15, I take away 3 is 12. It is 3. So the insect is the flower mantis. In our subsequent lesson, I think it's in the next lesson, how to solve addition and subtraction equation, we will learn how to solve this. All right, so let's go to slide 2. At the store, Johnny found 3 books that cost $2.64 each. When she got to the cash register, she gave the cashier a coupon to take 75 cents off her entire purchase, just like my mom. Which equation can be used to find T, the total cost of the books Johnny purchased? So we have this and that. So T stands for the total cost she spent. If you want to, let's look at our little bank, our answer bank. We're going to take numbers from here and retrofit it back into the other one. So what numbers do we need here? Let's go back to our word problem again. So Johnny found 3 books that cost $2.64 each. Which one shows there are 3 books, each one costs $2.64? So let's think. You have $2.64 for the first book, $2.64 for the second book, $2.64 for the third book. Is there another way to do repeated addition, multiplication? I think it's this one. Let's go back. So it's 3 times 264, 3 groups of 264. Then, when she got to the cash register, she gave the cashier a coupon for 75 cents off. That means she's deducting, reducing the price. So it has to be this one. So this is our equation. T stands for the total amount she spent. The total amount she spent is she bought 3 books for $2.64 each, and then she has 75 cents coupon. Now let's answer this. So it is 3 groups of 264. If you want to, we can add this up 3 times. I do not plan to do that. So it's 792. Take away 75 cents coupon. So 6, 7, 8, 9, 10, 11, 12, 7. 12 minus 5 is 7. I read grouping right here. 1. So she spent a total of $7.17 on her purchase. Let's do our next question. At the store, Johnny and her 2 friends bought a package of candy bars that cost $2.64 and a package of gum that cost 75 cents. If each girl paid an equal amount, which equation could be used to find T, the total cost of the items for each girl? So let's see. They bought a package of candy bars that cost $2.64 and a package of gum that cost 75 cents. Wait, did they buy 3 packages? That's right here. So they spent $2.64 on a package, and then on candy bar, and 75 cents on a gum. Each girl paid an equal amount. So it doesn't mean they split the cost. How many girls are there? There are 3 girls. So they split the cost by dividing by 3. So again, this is an equation. It's telling T is the total cost they spent equal to this. If it was just this by itself, this would be called an expression. But since I'm equaling it to something, I need to find its value. I need to solve this. So what's $2.64 plus 75 cents? So they spent a total of $3.39. But then they had to split it between them. I'm hoping you knew it was 3 because I know some kids when they see this they say, oh, it's just 2. So how many groups of 3 go in 3? 1 time. How many groups of 3 go in 3? 1 time. How many 3 groups goes in 2, 9? 3 times. So each girl spent $1. T is equal to $1.13. So that's the total cost of the items for each girl. So each girl spends $1.13. So we're going to go through different types of word problems, and we're going to find ways to set it up as this and that. Something is equal to this. So Matthew spent $6.50 on his lunch. This is $2.25 more than his friend Jackson spent on his lunch. How much did Jackson spend on his lunch? Hey, they forgot to tell us how much Jackson spent. Did they give us enough information about that? Nope, that must be the variable. So I'm going to use J. This is the amount Jackson spent on lunch. We do not know how much money Jackson spent on lunch. So that's why we're going to use J. So we are going to draw with the rectangular model, and using a rectangular model, we can come up with an equation. So Matt spent $6.50 on his lunch. This is $2.25 more than his friend Jackson. So we do not know how much Jackson spent on lunch. However, that is $2.25 more. So Matt spent $2.25 more than Jackson. And how much did Matt spend in all? Matt spent $6.50. So Jackson spent something. Matthew spent $2.25 more than him. And how much did Matthew spend? $6.50. So taking this, let's see. So our first rectangle says Jackson plus $2.25 is equal to $6.50. There is our equation. We're not going to solve it. You didn't ask us to solve it. Just want to know, can you set it up? So Jackson spent money. If he had spent $2.25 more, it would equal the same amount as Matthew. So J plus $2.25 equals $6.50. And why is this an equation again instead of an expression? Because it's this and that. It's equal to something. You can solve it. If it had been an expression, it would have just been this one. It would have been a variable or symbol with an operation and with a number. So let's go. I go this one. Just a couple more we get out. Maribeth saved $25 every week per week. She has saved a total of $600. For how many weeks has Maribeth been saving? They didn't tell us the number of weeks she's been saving. They did not give us enough information, but we could solve it though. So we know she spent a total of $600. So she saved a total of $600. And she spends $25, $25, $25, $25 each week. She saved $25 each week until she reached $600. Is that what it's asking? Let's say Maribeth saved $25 per week. She saved a total of $600. Do we know up to how many of them? So each week she saved 25, 25, 25, 25, 25, 25, 25, 25, 25, and we keep on doing it over. So each week we do not know. So we do not know. So we know is going to equal to $600. So how do you represent $25 per week? So it's 25 times W. So she spent $25 times the number of weeks equals $600. Is there another way to rewrite this? What could you ever write it as 25 parentheses W equals $600? Or what about 25W equals $600? And this is how you write its equation. So $25 each week equals to $600. And if you have solved, and it didn't ask us to solve it, but if I had to solve it, how many 25 is going to 600 to? Let's see, 50, 10, 24 weeks. So I would have to try 24 weeks. Aaron ran 1/4 the distance that Carolyn ran. Aaron ran a total of 1.5 miles. How far did Carolyn run? Let's use seed. I don't know. They didn't tell us. Amount of miles that Carolyn ran. So I don't know how much you ran. They didn't tell us. So Aaron ran a total of 1.5 miles. So this is Carolyn. She ran. Aaron ran 1/4 the distance that Carolyn ran. So let's cut this into fourths. So this is a fourth right here. So these are fourths. So Aaron ran a total of 1.5 miles. So 1.5 miles. So Aaron ran 1/4 the distance that Carolyn ran. Aaron ran a total of 1.5 miles. So we know it's C is the amount Carolyn ran, and it's 1/4 of. Wait, I'm sorry. Let's do it again. 1/4 of what Carolyn ran is 1.5. So here's Carolyn. If you take a fourth of this, it's going to equal to 1.5. So we could solve this. Another way to do it without this. Sometimes the pictorial model is easier. We know each fourth is 1.5 miles. So that means Carolyn must have, she ran 6 miles. So a fourth of what Carolyn did is equal to 1.5 miles. So again, in equation, you read the word problem, try to set it up using variables or symbols and numbers and operation. So let's try some more. Let's do this mentally. In our next few slides, next few YouTube video, I will actually tell you the algorithm or how to do this. Let's take mental math. Let's try to guess this. Something divided by 6 is equal to 4. Let's check and revise. I say 18, question mark. Now 18 divided by 6 is 3. Oh, 24 is the answer. So if you had to make a number line, whoops. If I had to make a number line, what number comes before 24? 23. What comes one be after it? 25. And draw a big dot there representing the solution is 24. Something, C, a symbol, plus 8 is 11. I know it without, this must be 3. So 2, 3, 4, 3 is the answer. So let's write another one. Can you write a real world problem that could be represented by the equation x minus 4 equals 11? When would you ever use this? Because I always hear kids say, when do we use this in math? So imagine like a store has some products. They're selling something. And they sold 4 of them, but they still had 11 left. So that's my real world problem. So a store has X number of products. They sold 4 of them. Now they have 11 left. How many did they order? How many did they start with? And that would be a real world problem. And inventory, that's called inventory. There are actually people who do this for job inventory audits. I used to do that when I worked as a bookstore. I used to count number of books. All right, so let's go through our last few questions. Let's practice a couple more word problems setting up as an equation. Mr. Coffrag wanted to rent a boat for today. The rental includes a $15 deposit, so you're going to put down $15 just to rent the boat, and $7.50 for each rental hour. Write an equation that can be used to find T, the total cost in dollars of the rental for 8 hours. Did they give us enough information here? I feel like they forgot something. Oh, they forgot to tell us the number of hours they rented. So we paid $15 just to have the privilege, but usually a deposit, they always return it back to you if you return a boat in good condition. Plus $7.50 each hour. I don't know how many hours, so $7.50 parentheses each. Is there no way you could have written this? $15 plus $7.50 each. Is there another way you could have written this? 7.50 h plus 15. Couple ways. Again, this is an equation because T stands for the total amount you spent. Total amount you spent is $15 plus $7.50 for every hour. So if the H, because kids always ask, what does this H stand for? All right, give me a number for H. Let's do 2. If you have rented this for 2 hours, 750 groups times 2 is $15, plus 15 is $30 you have spent. If you had done 1 hour, then it would have been $22.50. Let's go to our last one. Susie bought 4 packages of thank you cards that were each originally priced at $2.95. Each package of thank you card was sell for 25 cents off the original price. Write an equation that can be used to find T, the total cost of the 4 packages of thank you cards. Let's think. She bought 4 packages of thank you cards. They were priced at $2.95 each. So each one was $2.95. So that's 4 times $2.95. And then they were all or sell for 25 cents. So I take away 25 cents from each one, minus 4 groups of 25 cents. So that is the total cost you spent. Is there another way I could have written this? Because some kids say, I don't want to multiply twice. There must be a faster way. So you buy 4 packages. It originally cost $2.95, but then you take off 25 cents from that package, and you buy 4 of them. So either one is acceptable. So what we did today is we read through word problems. We tried to set it up as an equation, this and that, and we're not really solving it today, but in our next few YouTube videos, we will have solved it. So this is how to write equations or represent solutions.